Hello everyone, welcome to my channel. Today we are going to explore the draft tool in detail. We learn how to apply the correct taper to surfaces to ensure they are ready for mold making. Let's get started.
I got this magic in my fingertips, designing dreams with every click. Shapes and wonders coming to life. With CATIA I cut through strife. In my mind the future's clear. No more doubts, no more fear. Crafting visions in 3D. CATIA's the key, don't you see? I can reach the sky so high. Build my dreams, no need to try. With every tool I sculpt my fate. CATIA helps me innovate. Every line precise and true. Colors bright and brand new. Transforming steel into art. CATIA plays the
Hello everyone. Today I want to talk about the tools in the draft toolbar. This toolbar is located within the Dress of Features toolset. With these tools, we create a tapered or a slanted surface. This tool is essential in designing parts for casting or plastic injection molding. In the chamfer tools, we use to bevel an edge. There we would cut away parts of the surfaces adjacent to the selected edge. Then we replace the cut part with a new surface. Here we work with an entire surface. We slant the whole surface. Consider a rectangular cube. The draft toolset includes 4 tools in CATIA version 32. The first tool is called Draft Angle. I click on it to activate it. The settings window opens. This window has 2 main sections and 6 subsections. In the first section on the left, you see an option called Draft Type. There are 2 buttons in front of it. The first button is Constant. Currently, this mode is active. The second button is Variable. This option is also third tool in Draft Toolbar. You can access to this tool from Draft Toolbar 2. We review this tool in the next lessons. For now, we are not concerned with the second button. So we will examine the settings window in constant mode. Below these buttons, the first option is Angle. There is a box in front of it. Currently, the number 5 degrees is written inside. This is the default value. I double-click inside this box to highlight it in blue. I type the number 10. Remember, in practice, the draft angle of surfaces is much less than 10 degrees. I press the Tab key on the keyboard to use the second options box. The second option in this section is named Face or Faces to Draft. In this option, we select the faces of the part we want to slant. Here we can select one or several surfaces. I move the mouse over 3 surfaces of the cube. When the mouse pointer turns into a hand, I click. The names of the selected surfaces are recorded in the box in front of this option. The selected surfaces are displayed in brown. In front of this box there is a tool called Selection Sets, also known as the famous money bag. If I click on it, this tools window opens. The names of the selected planes are visible in it. Using its features, we can remove or replace planes. I remove one of the planes. So keep in mind that you don't need to cancel the command and reselect to remove a face. After selecting a surface, an orange arrow appears. If you select multi-surfaces in one time, you only have one arrow. This arrow points in a certain direction. The arrow indicates the direction of the slant. After completing the selection of surfaces to draft, I go to the second section. This section is called Neutral Element. The first option in this section is Selection. There is a box in front of it. In this box, we introduce a surface as neutral surface to the software. If this neutral element be a surface of our volume, the software shows it with blue color. In this state, the orange arrow moves to the center of this surface. What is the neutral element? Look, the surfaces selected in the previous step are to be slanted. Each of them is limited between two other surfaces. The slant starts from one side and reaches the other. Therefore, one of these surfaces connected to the selected surface must be the origin surface for the angle. However, this neutral surface must meet certain conditions. Its first feature is that it must not be parallel to the selected surfaces. This surface can even be one of the coordinate planes. This surface can even be a non-planar surface. Now I click inside it to highlight it in blue. First, I select the surface under the cube. You see that this face becomes blue. I remove it. You see that my cube is located above the XY plane. I select the XY plane as the neutral element. With these settings, I click on Preview. Now you see two semi-transparent blue planes on the surfaces of the cube. Below the cube, you see the angle value and direction in green. These two planes show you the direction and amount of slanting for these surfaces. Look at the figure. Currently, the orange arrow points upward. If I click on this arrow, the arrow's direction changes and points downwards. I click on OK. Since our neutral surface was the XY plane and the bottom surface was at a distance from it, the bottom surface of the cube also changed size. I set the view to the top. I set the transparency of the cube to 50%. From the specification tree, I set the paths sketch to show mode. You can see the change in size of the bottom surface. If we had taken the bottom surface of the cube as the neutral surface, this surface would have remained constant. To show this state, I double-click on Draft in the specification tree. The Tool Settings window opens. I rotate the shape in the workspace. I click on the bottom surface of the cube. I set my view back to the normal state. You see that the bottom surface remains unchanged and aligned with the sketch. Now assume we have such a shape. In the first section there is an option called Selection by Neutral Face. If you enable this option, the Faces to Draft option will be disabled. In this case, the software will enable the selection box from the neutral element sections. Now by selecting the neutral surface, all the side surfaces of the object will be selected. Here, all these surfaces will be sloped. Now we examine the third part of the settings window for this tool. This section is called Pulling Direction. First, let's examine its concept. Pulling direction means the direction in which the part is removed from the mold. By default, the software considers the direction perpendicular to the neutral surface as the exit direction. In complex industrial parts, the exit direction is not always perpendicular to the neutral surface. Sometimes the part needs to be removed from the mold at a specific angle so it doesn't get stuck. This is where this section comes in handy. Look at the settings window. There are two options in this section. The first option is called Control by Reference. This option is currently active. The second option, which has a box in front of it, is called Selection. Inside the box in front of Selection, Phase 2 is written. This is the name of the plane we initially created to slant the cube. Now I deactivate the Controlled by Reference option. You see that inside the selection box, Pulling Direction is now written. Here the software asks us to provide the exit direction. So how should this direction be? This direction can be an edge of the model, a line or an axis, coordinate planes, or the compass direction. Now, what effect does selecting, for example, a diagonal line have on the design part? If I select a diagonal line, a 10-degree slant is applied relative to that selected line. In this case, the initial shape of the cube changes according to your selection. Now, there are important tips here. You can draw a line in a space beforehand and introduce it as the pulling direction. Look, I have drawn 3 lines in a space. One is perfectly aligned with the face I want to slant. The other 2 are partial and non-aligned. I keep the previous settings the same. I uncheck the Controlled by Reference option. I click in the selection box. I select the line and click OK. The final shape is visible. Now assume we have a glass of water. I slant it using the draft tool. I select the cylinder's side surface for drafting and its base as the neutral surface. I set the slant angle to 2 degrees. I right-click in the selection box of the pulling directions section. I select the Z-axis as the exit direction. I click on OK. You can see the result. Just one more point. Pay attention to the direction of the orange arrow created here. The direction of the arrow will be the direction of removal from the mold. I will conclude this part here as it relates to advanced status. I will explain it in detail in the next lesson. Good luck. See you in the next session.
Let's build the future.